So then, Lucy, I
Uh,
tip my hat.
yeah. Yeah. Okay, should we get started?
Sure.
Yeah.
Absolutely.
Okay, I'll just briefly introduce. I'm so excited to have four guests here today for an ISEEC, which is the International Society for Ecology and Evolution in Cancer, hosted EvoChat. So we have Carlo Maley, he's from ASU, and he does all things cancer and evolution. And then we have Joel Brown from Moffitt, and he does all things squirrels and ecology and cancer. You can already tell this is going to be an exciting event based on just those two descriptions. Then we have Lucie Laplane. She's from CNRS, right? You're still at CNRS? Yes. And she's a philosopher of biology, so that's really exciting to add to the group, working mostly within cancer in the last few years or so. And then we have Ben German Spada. He's a graduate student at the University of Bordeaux that's also in philosophy of biology. So they're going to talk about how we define cancer, and I'm not going to take up any more space, so go ahead and take it away.
All right. I'm going to try to moderate this, but Amy, could you monitor the chat for
Yeah.
questions and things? And hopefully we'll have more time for people just to speak up, but I think we'll initially have a discussion among the four of us. Um, so this is sort of a two-part, or this came out of two different efforts. So Joel led an effort with his Moffitt colleagues as well as um, Johns Hopkins colleagues. I see Sarah Almond is on the call here as well, to think about definitions of cancer. And then Lucy and Benjamin and um, Thomas Pradou and I have been working on sort of trying to take the next step from their work. So we'll lay that out for you in this discussion. But I think Lucy actually brought up an initial question I wanted to start with, which is um, what's well, actually, sorry. Well, I think where we should really start is what's wrong with the traditional definitions of cancer. So, Joel, what was your guys' answer to that question?
Right. So I think, when I first was invited to participate in cancer by Tom Vincent, my game theory mentor, and Bob Gatenby, who's been sort of a thought leader in applying evolutionary therapies and whatnot in cancer, I'd actually never really paid attention to the definition of cancer. But what I noted is you had a whole group of people that were imagining cancer as a jumping levels of selection, where a cell that had been part of the whole organism was now its own beastie. The ecosystem, the tumor was its ecosystem, and the patient was sort of the planet Earth. And I noticed that that's kind of how people operated. And when I was hired in integrated mathematical oncology, the various models of cancer population dynamics. They just draw straight from models of population ecology. They draw from models of evolutionary biology. And so at that point, it was like, wow, cancer is just jumping levels of selection. But then I became the person that was their nightmare because I'd walk around and ask people to define cancer, whether it was at the NIH, this was long before I was employed at Moffitt, and would either get, oh my gosh, it's hard to define or it's complicated, or it was the usual, it's a disease of uncontrolled proliferation with the capacity to invade other parts of the body. And that shows up again and again and again. Even the Swedish National Cancer Institute definition, as of today, looking at it, is it's when a cell begins to misbehave and will not cease proliferating. And then it doesn't die when it's supposed to die, sort of a rogue cell. And so for me, that kind of embarked on a journey then of where I saw cancer then as kind of this jumping levels of selection. That seemed to be how people were operating, subject to evolution by natural selection. So I often refer to it as a speciation event. And sometimes that went over very well. Other times, because speciation is such a loaded term, it didn't go over so well on there. But it was clear that the problem with the current definition, so I'll stop there because we need to let other people talk, is I think it describes what cancer does, but doesn't actually say what cancer is.
Okay, cool. Benjamin, you've been thinking a lot about this. What's your thoughts about what's wrong with the traditional definitions of cancer?
Well, first, I agree with Joel, and I think this is one of the first idea which pushed us to also do this work. Mainstream definition of cancer focus on the outcomes of the process, not really on the process by itself, which makes a lot of sense, especially when you think of cancer as a disease to cure in humans. But yeah, I'm doing philosophy of biology, and my PhD focuses on cancer under an evolutionary perspective and comparative oncology. And when you want to do comparative oncology, it appears quite quickly when you read the literature that usual definitions are not enough. I mean, it goes back to already in the middle of the 20th century, people were trying to explore tumors in insects or in invertebrates in general. And every paper, the conclusions were, well, we can't tell you whether this is cancer or not because we don't have the conceptual theoretical tools to call this cancer. There are some lumps, there are some uncontrolled proliferations, but for now, the only way we know how to frame cancer is based on humans. And so it's another problem. It's not only focusing on the outcomes, but it's heavily, and for many obvious reasons and rightful reasons, focused on humans, or at least mammals. And so, of course, when you wonder, okay, where can I find cancer across the tree of life? Or if you define cancer as something which looks like what you find in humans, well, obviously you won't find it in many other groups than mammals, maybe some vertebrates. And if you want to do exhaustive comparative oncology and to be serious about it, you need to be able to take into account the rest of the tree of life.
Okay, so there's sort of issue of both practitioners and human cancers, and then also when we try to generalize to other species. But it seems to me like among the practitioners, and this is mostly the pathologists that end up engaging with this most directly, it's separated by the specialty, and within any particular organ system, they have their own criteria for when they're going to call it cancer. So do we need a definition of cancer, or is it okay just to have each specialist sort of define it as they see it? I mean, Lucie, do you want to jump in on that one? And
Uh,
then Joel?
yeah, before I jump on this one, I would also say if I take the philosopher hat, we currently have no definition of cancer. What we have is two ways of characterizing cancer. One is this idea of uncontrolled cell proliferation that with metastasis, let's say. The other is the attempt of describing cancer through the hallmarks, but none of them really provides a definition if a definition is a set of properties that allow to identify every instance of cancer and exclude every instance of non-cancer. So even if you focus just on human, for example, the definition of uncontrolled cell proliferation and invasion doesn't discriminate between blood cancer and premalignant blood pathologies. So really, we have no definition per se. And then whether we need a definition, I think it really depends on the field, and it looks like what Benjamin said already is indicative that for comparative oncology, if you don't have a definition, then you don't have a tool to say whether one specific instance is a cancer or not. And therefore, several questions that are important for comparative oncology can't even be asked, really.
Yeah, this really came up for us when Amy and Athena Actipis, Amy Body and Athena Actipis, Michael Hochberg, and others were trying to do this survey across the tree of life and ask what did cancer look like in other multicellular organisms. We suddenly realized, oh, we don't have a definition that helps us distinguish this. So I'm sort of coming at it the same way that Benjamin does, is we really, it rears its ugly head when you start trying to do comparative oncology. But I think also, even if we restrict it to humans, there's this issue of it seems like there's a cancer-like phenomenon that happens in the immune system as well as in the solid tumors. And at the moment, we just rely on the specialist to understand how badly things are going wrong in each organ, but we don't have a real clear conceptual way of digging into it, which is why I think, the work of Lucy and Benjamin is so valuable to help us think clearly about these issues. And that's really the origin of this conversation today. So I want to come back to Joel. So when you started engaging with this, can you tell us about sort of the process you went through as you developed your paper? What were those conversations? What were the motivations?
Sure. Well, so for me and Lucy, as a with my biomathematical and theoretical background, I tend to be a stickler for definitions. They may be right or wrong, but they're useful or not useful. And so this notion of not having a definition of cancer, or that which shall not be defined, to me was like, well, to me it seemed like intellectual timidity, but maybe not. I think that people like Ken Pienta is a cancer ecologist. Carlo, your papers with Mel Greaves, I consider to be one of the early papers recognizing cancer as a jump in levels of selection and then being driven by natural selection, because that's going to be the key element. Is I think what separates cancer from all these other diseases of unregulated proliferation or goofed up some sort of goofed up sort of metabolic pathways, somatic mutations, and whatnot, is I think that cancer ultimately is cancer. Now, there's the cancer initiation, but is cancer the moment it is being propelled by evolution by natural selection? And in fact, my whole entry into the field was at the invitation to be an evolutionary ecologist. So, in a sense, I was kind of pre-adapted to be useful by thinking of alternative definitions. And so it was very nice of Ken Pienta to pass along a paper by Mark Vincent, a physician in Toronto, who in 2010 does literally a surgical dissection of cancer as a speciation event, started to dig more deeply. And then you discover the Julian Huxley um, of sort of the modern synthesis. He has a paper in 1956 in which he describes cancer as like a speciation events. Even Hanahan and Weinberg describe the hallmarks as being akin to a Darwinian process. And then Peter Duesberg in 2000 actually describes cancer as a speciation event. So there's this momentum, Carla. I could just see it. And as I said, your work I would include in there. And then there was Bob Gatenby and Tom Vincent and many other kind of individuals. And so with that in mind, as I was really keen to redefine cancer, but as I said, I had this somewhat sort of edgy, and I still do, view it as a speciation event and then clarify what it means to be jumping levels of selection in which it is subject to evolution by natural selection. So hence, cancer is best understood as first principles of ecology and evolution. And obviously, Bob Gatenby and Tom Vincent were seeing it that way back in 2001 on there. And so it was actually through getting a group together we had between John Hopkins and Moffitt was on Ken Pienta's porch, and we had wrapped up a very enjoyable couple of days of chatting science during the day, wine and beer during the evenings. And I remember Ken Pienta turned to me and said, "What paper would you really like to write?" And I said, "Updating the definition of cancer." And so that led to a discussion. He brought the whiteboard out on the patio. That way I could see squirrels. That was perfect. And on that whiteboard, I put up speciation, and Ken and the other discussants, Sarah Ahmed was there, as was Bob Gatenby. We began to mush it around, and Ken was very practical. Hey, look, there was no disagreement on how we were viewing it, that evolution by natural selection was essential, but Ken was being very practical in what can sell soap, what can help satisfy Lucie's or others' requests for how do you know it's cancer, how do you define it not, and how do you honor the tradition of how cancer has been defined. And so consequently, I thought it worked out just great. We came up with the definition then of cancer is a disease of uncontrolled proliferation. Great. That by transformed cells, that kind of captures the jumping levels of selection or the mutations, subject to evolution by natural selection. And so for me, the distinguisher for Ben, for comparative oncology, for within oncology, is it is a disease. It is relatively unique in that sense, perhaps unique, in that within the patient, it's driven by evolution by natural selection.
Great. I realize that Sarah Ahmed hasn't really had a chance to get any warning that I'm about to call on her. But since Sarah, you're the second author in this paper, and we're lucky to have you in the audience, is there anything you want to add to that story of sort of how this paper developed or the perspective you guys developed? she may be away from keyboard, so this is unfair with me.
Oh, but I'm glad you did because I know obviously she would be an excellent person to be able to chime in.
All
So
right. Well, if she's has a chance or wants to participate, please jump in, Sarah. Okay. Um, so then let's sort of take that next step. Benjamin, you're the one who really picked up this question, and I know it's a chapter of your dissertation that you're about to defend in a few weeks, and congratulations on that. So tell me about sort of where where we jumped off of the Joel's paper, and so sort of what the distinctions might be, or where how we wanted to extend it.
Yes. So first, going back to your first question, do we mind if clinical oncologists have specific definitions depending on the type of organ, type of cancer they work on? Uh, I think we shouldn't mind, for obvious reasons that those people need to be able to do their jobs. So I'm not gonna be the type of philosopher who's obsessed with all encompassing definitions that there should be only one definition unified for everything. However, I think that a universal definition can be useful. And I think that what we try to do together with Lucie and Thomas, we might be onto something. Because I do believe that obviously for comparative oncology, we need something greater. We might say, okay, but it only works for comparative oncology, and for human oncology, they can keep their very specific definitions. Yes, unless universal definitions can help to shift or to reframe how clinical oncologists conceive cancer, and if this has pretty practical consequences. And so for now, I don't think we are there yet. We don't have any strong arguments going this directions, but we have some intuitions. There are some things, and this is why I'm really willing to pursue this article project we have, because if it's true, that would be perfect. But we would have a definition that would work both for comparative oncologists, for people who are interested in cancer in non-human organisms, and something that will also be of interest for clinicians, which also would be, I think, really cool, because that would force clinicians to take interest in evolutionary approaches of cancer. Because for now, people who work on cancer, except if they know, I mean, most of the time they don't know much about cancer outside of humans. And for now, we haven't been able to produce any good reasons to tell them, hey, you guys really should take a look at what people do in comparative oncology, about what evolutionary biology can do if we use it to reframe cancer. That was one thing. Sorry, I got lost. And your question was, oh yeah,
Well, I
quoting
guess
Joel's.
maybe yeah. What was it that you wanted to? What were you not satisfied with? I guess with Joel's paper. What was the next step you wanted to take? Where do you want to dig in there?
So Joel, tell me if I'm wrong, but the way we understood your definition, which I should have noted somewhere. I remember there was notion of transformation of the cells. There is evolution, which produced transformation. And I think in somewhere in the paper, you explains that so the hallmarks of cancer are instances of such transformations. Is it right?
yeah, so we actually just published a paper. Boy, I'll have to get out there, which one of my graduate students, Ranchini Bhattacharya. That was actually, well, thank you. This, you guys, that was kind of kind of big career goal number two. Career goal number one was sort of, can we redefine cancer? Number two was really nailing down the hallmarks of cancer's ecoevolutionary processes. And that particular paper just was published last year in Cancer Discovery. And there, what we try to do is, and I think Ben, what's important there is that color wheel. Um, it's eye candy. It looks great. It characterizes a bunch of properties, but is it a wheel? And so what we do is we kind of unwind it. We unwind the color wheel and we identify, and I won't go into the details, but I invite you to take a look at the paper, where some of the hallmarks of cancer are basically the processes that must happen for cancer initiation. They are basically, they themselves are not subject to evolution by natural selection. They are the things that must happen for them to be able to jump levels of selection to go from replicative mortality. Well, every species that's subject to natural selection has that. I mean, that bunnies have that. Bunnies have uncontrolled proliferation if given a chance in Australia. And so there's a number, so we define three of the hallmarks kind of fall out nicely as the transformation process. And then once that transformation process happens, and I would invite people to take a look at the AACR website with their under their definition of cancer. They have this wonderful sort of figure, sort of defining uncontrolled proliferation. And what they have is mutation, mutation, mutation. The cells start to look wackier and wackier. I love it. They start to look crazier and crazier. And then you get this glob of really scary looking cells, and they call it uncontrolled proliferation. I would say that diagram basically only describes the cancer initiation, the transformation. But upon transformation, the evolving evolvability, angiogenesis, avoiding the immune system, this quote, dysregulated metabolism, all of these becoming independent of signals, all of those now describe a disease that is now being propelled by evolution by natural selection, that is progressing via evolution by natural selection.
So I want to call something out just to be clear, because you're using transformation in a non-standard way. Like the traditional way in cancer describe transformation as the change from a benign tumor to a malignant tumor. So it's like the final step to go from precancer to cancer. You're redefining it as the start of the cellular evolutionary process.
That's right. So we would be seeing it as that cancer cell, or as Bob Gatenby has suggested, that collection of cancer cells that
Right.
crosses the line, that performs that jumping levels of selection, like you described so beautifully in your paper with Lucie.
So
Um,
I guess I would call that neoplasm at that
sure,
point.
sure.
In fact, that's sort
Oh,
of where we ended up in our discussion, is that there's this evolutionary process of neoplasms, and then there's a further distinction you might want to draw between what we might call a cancer or a precancer. And we'll
right.
get to
And
that in a
Carlo, I would invite Ben and Lucie to kind of comment. I think you hit something kind of on the head. And I'd say that as soon as you describe the neoplasm or clinically detectable or clinically relevant or those steps, again, one now is getting back to what has done. So you have a beaver that begins to build a dam. You have a beaver that begins to do a process. You can describe each process of eventually raising the water table and flooding basements and communities in which the beavers are doing wonderful. By the way, I love beavers, so I support that heavily. So I would say that you are describing the steps that once that transformation has happened, these are the things it causes. These are
second.
the unintended consequences.
Yeah,
These are the
I want to
manifestations.
hang on that actually for a second, because we totally agree with you that there's an important distinction between the evolutionary process that seems fundamental and then what evolves are in humans are the hallmarks, but in non-humans are not necessarily the hallmarks. Right. And so for us, my problem, my quibble maybe with the paper was
Sure.
using the term transformation seemed to pack the hallmarks into that term transformation in your paper, if I understood it correctly. Um, and that limits the sort of, well, that sort of hides maybe some of the problems from the earlier definitions of these phenomena. And so we wanted to make a distinction between the evolutionary process of cancer or neoplasm from what evolves, and that's going to be particular.
Sure.
So let me come back to Benjamin. Can you give us the definition of neoplasm and cancer that you came up with, or that our team came up with?
Yes. So it's really in the same path as what Joe produced. So we define cancer as uncontrolled cell proliferation due to cell level evolution that would be fatal for the organism if left untreated, so that we can, as you said, make difference between neoplasms, which are not necessarily, are not lethal, and cancers, which would be lethal. And to this, we added another concept because the universal definition is great, but the problem is that we lose the specificity of what cancer is when cancer uh, maybe reaches its full potential. It can do many different things, sometimes in the same species.
Oh, Benjamin, can I stop you for just a moment? Because I think you're
Yeah, sure.
touching on something like so cool and important. And that is, if you define cancer as being propelled by evolution by natural selection, and that the organism itself is the planet Earth, your statement of living to its full potential somehow suggests that a species that doesn't keep expanding and taking over somehow is not living up to its full potential. That somehow those deep sea creatures that they find at low abundance living in deep sea vents that have never gone beyond chemosynthesizing, poor guys, they've never lived to their full potential. But I think if you give the cancer cells agency, judging them by what they consequently do, I think then muddies the water. Just a thought. So just because again, I think you're focusing on what it does, and that term living to their full potential. I love it.
Yeah.
Well,
Well, to be fair to Benjamin, that's not a key phrase in the
Sorry,
paper.
that may not be fair. That's the debater in me. You just kind of threw me one high and outside.
Right. Well, but it's related to the concept of what does once you get this evolutionary process going, what does evolve. So I think Benjamin's trying to get at that. So let's throw it back to Benjamin.
yeah, I mean, I just said full potential because that was the first, that was the first way for me to phrase that cancer the outcomes of cancer can be manifold. There can be many ways for cancer to develop. It can be instantiated through the hallmarks, but it doesn't have to be. In fact, with Carlo and Lucie, we believe that the hallmarks are very specific outcomes of cancer in the context of mammals. And so we come up with this concept of affordances. This is something we often use in philosophy, but there is a whole lot of literature about this, and we didn't want it to go down this rabbit hole, so we wanted to make it simple. I don't think this is simple in any way. But affordances, this is how I framed it in my dissertation, are properties of the cell environment system that define the range of potential behaviors available to cancer cells. And some of those behaviors might be selected because they bear fitness consequences. So basically, you have the cell level evolution, which is the process. So as you said several times, what cancer is. But then we also wanted to frame what cancer does, but in a way that makes sense of the universality, the wide range of cases in which cancer exists. And so affordances are what cancer cells can do depending on the constraints of their environment and their own constraints. So for instance, if there is no way to create new blood vessels, there won't be any angiogenesis. So angiogenesis we won't be part of the affordances of the cancer cell because it's just not there. Then there isn't there aren't the constraints or the potential for the cancer cell to do that.
So, Benjamin, if I can just run with that, 'cause I think that's absolutely lovely. But Lucy, obviously, you need to have a chance to get in here. So, to me, as an evolutionary ecologist, what we see in nature is an interplay between what is evolutionarily feasible and what is ecologically acceptable. And I think you have so beautifully outlined that, yes, like any species on this planet, the tissue of origin, the species of origin, even the individual patient, all of the unique contingencies, this kind of replaying the tape of life with each cancer means that you fully expect what's evolutionarily feasible for a cancer that initiates, say, in an insect versus one that initiates in a whale or somewhere else. Those forward very, very different evolutionary potentials. And then the environment is strikingly different. I mean, even just a metastasis within a patient. So you have wildly different environments. So in that sense, I think then you're just describing exactly what I expect to see a species do.
Mhm.
And so, in that sense, yes, I would expect each cancer to carry with it the phylogenetic baggage of the organism and tissue from which it originates. And then it carries the ecological challenges of whatever is afforded by that environment. Does that kind of make sense? Or what do you think?
Yeah,
And
Lucy, do
Lucy,
you
I'm
want to
sorry.
jump in?
No, I think I don't need to jump in right now.
Okay. So I see sort of two levels of affordances, of what can evolve. So there's what's possible, which is a sort of large set, but many of those things that are possible might be deleterious, and so the mutations that cause them will be immediately weeded out, or it'll be fatal to the cell. And so within the what's possible, there's what's selectively advantageous, and that's the things you're going to observe. I kind of think of like affordances or what's possible as the borders on a mold, and you're pouring in the evolutionary process and it's starting to
Right.
explore the space that's in the mold. And sometimes it'll spread down one channel and sometimes it'll spread down other channels. But the mold is different for different organisms. What is advantageous and different for different organs, right? What's advantageous for a cell to do in a kidney is knock out VHL initially, right? But what's advantageous for a cell to do in colon is knock out APC. And so this idea of affordances basically
Right.
gives us both the universality, but the specificity of the context. And it's, Joel's idea of what the ecosystem can support gives you that specificity.
Carlo, I think that's fantastic. Yeah, and I think I would agree with that completely. And I think what's really interesting too, I guess where I would run with your mold business a little bit is it perhaps becomes a little bit rigid, because I picture the mold and I understand, all metaphors have this elements to it and whatnot, but think about life, it's also altering the mold. So
Yeah,
you
right.
have so to me as an evolutionary ecologist, it's those environmental feedbacks. And
Yeah.
so, you kind of described a Waddington landscape that yes, there's going to be alternate stable states. Once you go plowing down one particular evolutionary trajectory, you burn bridges while opening up bridges. And of course, my favorite in terms of watching evolutionary bridges being burned and where a species can still be driven by natural selection, even if it's driving its own destruction, are cave fish, particularly the famous cave fish in Mexico, where you've got like 25 different caves, all nicely in a line. Every one of them evolves a cavefish. They all converge on very, very similar morphologies. None of them is more closely related to each other than they are in the fish in the stream. And each of
Mm.
those caves lasts about 10 to 25,000 years. And once they evolve to be the best cavefish they can be, they will never see the light of day again. And so, again, I'm going to, Benjamin, pick up on another issue that has come up and I've had many discussions, and that is if it if its full potential is not to kill the patient or kill the organism, is it cancer? And I would again argue that looking at agency from the cancer cell's point of view, we have plenty examples in nature of what we would call the evolution of niche conservatism. So a cancer cell isn't going to feel like an inferior species because I'm incapable of destroying my planet. Most
Right.
species on this earth hopefully will not destroy the planet, notwithstanding humans. Who knows? We will see. And so I think, again, there are probably
So
many, many.
I would call that a neoplastic cell. So we
Sure.
started with the definition of neoplasms as sort of uncontrolled cells that are evolving. And then we recognized that there is an important distinction of a sort of disease that we need to intervene on and to preserve from those that can live perfectly happily in their little niche, right? And so that's why we got to so we have the neoplasm definition and we just add that would be fatal if you don't intervene as to distinguishing the benign
Got it.
neoplasms, the malignant neoplasms. Um,
Right.
I do still have a quibble with our definition, which is would be fatal is like predicting something about the future that you can't necessarily know now. Um, and and I don't have a better answer to that, and maybe somebody else can improve that.
Sure.
But it throws it back onto the sort of experimentalists or the clinicians of we have to try to recognize what's going to be a dangerous neoplasm from a non-dangerous neoplasm
Right.
and what we need to intervene on.
Right. Well, Carl, let me just throw this back, and obviously when they want to open up the other folks. So, but it's intriguing. So if we're successful in adaptive therapy, if we become successful in anticipating and steering the ecoevolutionary dynamics of cancer, so it's now livable, is that now just a neoplasia? Is that now no longer a cancer?
Well, we said a cancer would be fatal if you don't intervene. So the fact that you're intervening there doesn't stop it from being a
So,
cancer.
what if the immune system by itself is able to successfully intervene in an adaptive therapy format? So, in other words, is it the external intervention that is required, or what if the body itself manages to come up with its own sort of adaptive therapy through the immune system? Would that now
I think that happens all the time, right? We get tumors that don't progress, they regress, they sit there, and we want to distinguish those as as not as important, not as worrisome, right? So I would call those neoplasms and not cancers.
so that means your definition of cancer really requires the worrisome outcome.
Yeah, yeah,
And yeah,
and for me, it's the neoplasm is what is universal, and you can start looking at uncontrolled evolving cells in any multicellular organism. Um, but there's a practical concern if you want to preserve a human or an animal's life that you care about. There's a practical you care about whether this evolutionary process is going to be fatal or not.
so would you use a different word for an invasive species that doesn't go on to do anything horrible to the human ecosystem versus an invasive species that is threatening to human health, to agriculture, life? So in other words, we just call them invasive species, and then we call one pernicious and malicious and one fairly innocuous.
Yeah, it's a good point because by our definition, you could get a tumor that invades or metastasizes even, but if it's not going to be fatal, we would say, no, that's still a benign
Right,
neoplasm, it's not a
right.
cancer.
Yeah,
That's where we do dramatically depart
right.
from the current definition.
And certainly from prior definitions.
Yes. Yeah. But notice that this like invasion through the basement membrane, which is a problem both within humans for the hematopoietic cancers and is a problem for plants that don't have a basement membrane or placozoans that don't have a basement membrane. Um, that all is handled by the what evolves, the affordances, but the underlying process is the one we totally agree with you about. That is, it's this evolutionary process that's driving it, and what evolves depends on the constraints of the particular context, the affordances of the particular context. All right. So actually, I think this would be a good time to open it up to the audience. Are there people that want to ask questions, pose challenges, other comments?
Well, the first person I'd like to invite to comment is Amy. Thank you. You've been listening to all of this, and so I'm imagining I haven't been able to see your thought bubbles. And Amy, I always like to be able to see your thought bubbles. So if you're willing to share a couple thought bubbles, that would make me happy.
Sure, sure. I had a question in the chat, but that turned to defining neoplasms instead of cancer. So maybe we should focus on the definition of cancer.
No,
Um,
I think this is appropriate to talk about definition of neoplasm. I think we have to
okay.
do that.
Because
Yeah.
then I started to think, and maybe you could expand on this, Carlo, but then does that mean as we age, we're all just full of neoplasms? Those are like somatic mutations, clonal expansions that we see. Yeah.
Yeah, actually, this is a part where I depart a little bit from Joel, that I think just in our normal biology, our cells are dividing, they are mutating. There is some process of evolution already. And so I don't see this initiation going from no evolution to evolution. It just sort of supercharges it or speeds up the process. Joel, is that fair?
Well, so I think, it's interesting, and it here I think is one of my favorite devil in the details of evolution by natural selection. And when I learned evolution class, it was, beanbag genetics, and you had a selection coefficient, and with that selection coefficient, either the big A allele or the little A allele or some sort of overdominance and whatnot. But that little S, that selection coefficient, to me, the ecologist to me, that's all the cool stuff. That's what you live and die by. And here they are, they're just turning it into S, just the selection coefficient. And then it dawned on me, and this I think is a very enjoyable discussion. This would be actually, Lucie, I think would love to join you in writing a paper on this. To me, you can have lots of selection processes. And so somatic mutations are happening all the time. Pebbles on a beach striate based on the sizes, grain particles. So there's lots and lots of selection processes. To me, what makes evolution by natural selection, this is just me, is the full sort of Darwinian Monty. And that is you have to have heritable variation. It's fine. But you need, and I think it was central to him, a struggle for existence. So that means the intent to produce way more offspring than can survive if given the opportunity. And then, of course, the heritable variation. So I think a lot of the what we call clade competition or clonal evolution, Amy, why I wouldn't call it cancer yet is I don't think it doesn't fit the struggle for existence yet. They're still kind of obeying some of the laws of tissue control and whatnot. But that gets, as I said, I'm opening up that big can of worms, and that is, can replicator dynamics, as we often use in game theory, is that a full representation of natural selection? I'd say no. Until you actually have the struggle for existence, individuals are born and individuals die in this creative destruction. It's not, anyway, sorry, that was, you kind of opened up another kind of can of worms, but that's where I feel very comfortable in having Cancer and Amy saying that no, not yet, even though you may have a whole bunch of cells that want to jump or could jump or whatnot, they have not. Once it's when they jump, boy, then the sales of natural selection, just as Carlo said, it just accelerates.
So Yannick's been very patient. He says hand up, so
Yes.
I'll let him
No,
jump in here.
no, that was a question for you, Carlos. So I was wondering, so if to call it cancer, you need the disease to be lethal, okay? When do you decide that it is? I mean, do you need to let it run its pace and, once the animal is dead, you say, yes, that was cancer? Or is
No,
there
so
an earlier stage when you can say, well, I mean, it's bad enough, so I'm not sure whether it will recover, but let's call it cancer. I mean,
yeah, so I think you can see what the clinicians do. So they've noticed that if the tumors invade into the neighboring organs, that's a really bad sign. It's probably going to be fatal. That's why they call it cancer. Or if it metastasizes, that's a really bad sign. So this is what I was talking about earlier about it becomes back to an observational question or experimental question about what are the signs that it's going to be fatal, because obviously you can't wait to to kill the patient. And that's also why I said I was uncomfortable with this definition, because you can't be sure. But clinicians have to act in the face of uncertainty. But we can collect information about which things in large populations, which phenomena were indicative of it being fatal.
okay.
And that's going to be different in different organisms, right? My some of my botanist colleagues don't like calling fasciations cancer in plants, that sort of cresting that you see in plants. They don't like calling it cancer because it's not fatal. And I'm like, well, it's still cells dividing out of control and evolving. It's just within the affordances of a plant, it shows up quite differently, and it interferes with flowering, so it reduces their fitness. It makes them blow over more often, so they do break and die more often, but it's not necessarily fatal. So it's certainly a neoplasm. I'm not sure if we'd want to call that a cancer, but I think understanding it as a neoplasm is still allows us or helps us do comparative oncology. Athena has a number of things she put in the chat, and she's raised her hand, so I want to give Athena a chance to talk.
Athena, first, good to see you.
Great to see you too.
Hello, hello.
I just want to offer that, one way of conceptualizing it, which could help to kind of take into account both sides of this is, if you look at cancer as basically situations where the mechanisms that usually will suppress this sort of jump to this other level of selection fail. So, you have all these intrinsic mechanisms right within the cell where the cell is like regulating itself. In terms of p53 and other genes that play that role within the cell. And you have like the neighborhood mechanisms, right, where cells are monitoring what their neighbors are doing and sending survival signals or apoptotic signals to each other. Then you have the immune system, which is sort of working on this higher level to sort of see if there are regions where things that are happening that shouldn't be happening. And all of those sort of work together. It's like a multi-level, multi-layer system to try to keep the cellular mutations and, other, epigenetic changes and all that could lead to that jump to keep that from happening. So, if we define it in terms of the sort of failure of those regulatory systems, then that should be associated with death if organisms don't die from something else sooner. But it also gives us something tangible and measurable that we could look at in terms of, should we call this cancer?
Great.
Also, it can help specify what is meant by uncontrolled, because I have an issue with the uncontrolled part of our definition, which is difficult to address. What do we mean by that? So that's one way maybe to help with this issue.
Right, and that gets back to Joel's definition also in terms of the switch from the normal behavior of tissues to the uncontrolled, or where you see evolution happening, Joel. We have another author on the brown paper. Bob Gatenby has his hand up. Bob, great to see you.
Howdy.
Hi. Sorry, I'm late. I was doing a grant review and it just ended. But I just wanted to, when I first started thinking about cancer, I really thought of it as like a ball of cells that are just slowly growing. In fact, that's how it's often depicted in, diagrammatic kind of ways. But in fact, most cancers develop in ducts, so that there's a distinct geometry. It's a tubular geometry, and they are maintained in the duct. So they're growing into the duct. There's distinctive diffusion reaction kinetics because the blood vessels remain outside of the basement membrane, so that there's oxygen, glucose, growth factors are diffusing into the duct and being metabolized, so that there's going to be a concentration gradient within the duct. But traditionally, cancers are diagnosed only when those cells invade through the basement membrane. And at that point, you have an invasive cancer. So you go from ductal carcinoma in situ, which is the standard, into this invasive cancer. The in situ cancers, though, are proliferating. I mean, they are probably you could call them uncontrolled proliferation, and they are evolving. But that's a step before the invasive. So the breaking through the basement membrane is the essential transition for in situ cancer and cancers that are not significant to cancers that can become fatal. And so I just want to kind of define that as because that distinctive geometry of early evolution of pre-malignant cancer cells, to me, is very important. And there's a unique kind of a geometry to that, which I think we should be keeping in mind as we discuss this, process.
Yeah, thanks for bringing that up. But also, and one of the things you pointed out there is that invasion is what makes it or leads to the fatality. And one reason we wanted to distinguish between the neoplasm and the cancer based on this fatality was to help bring along all the knowledge that clinicians have, so that they wouldn't just say this is bogus, we know cancer, right? It hopefully integrates their knowledge with a perspective that allows for universality across species that don't have basement membranes, or for neoplasms in like hematopoietic system that don't have that basement membrane issue. Great. All right. Well, Benjamin, is there any things that we haven't touched on that you wanted to bring into the conversation?
And maybe just to specify what we think affordances can be useful to. So, as I said, to identify the specificities of cancer while remaining large enough to encompass everything. And I think, and now this is more a bet than a claim, but I think it might be possible to create new categories of cancer. So maybe some cancers in plants or algae or fungi share similarities with cancers of species which are very distant phylogenetically. And maybe those commonalities are the outcome of shared or of similar affordances. And when we think of affordances, different type of constraint, the same constraints can maybe produce the same outcomes. And so I think our goal for a useful concept of affordances will be to have something that can build bridges between the affordances across tissues, across species, and maybe this will lead us to realize that, oh, for all this time we thought the very relevant distinction was between cold tumors and hot tumors, but maybe that's not really important. What matters is a distinction between cancers, which are the produce of affordance X, and cancer, which are the produce of affordance Y. So again, this is very speculative, and that's a bet. But I think if we manage to produce this type of argument, it will make appear more clearly the benefits of thinking of cancer in an evolutionary perspective. Because there is one thing I'm convinced, which is that if you want to think of cancer through evolution, it is because you believe there is a way to reshape, to reconceptualize cancer, in the hope, of course, that this reconceptualization will be fruitful for clinicians.
Yeah, I agree. And I wanted to add to that that not only does this perspective that Joel and Bob and Sarah and we've come to this sort of evolutionary process, and then within these constraints of affordances, not only does it help with the universality of the definition and the specificity, but I think it does bring up new questions, research questions and perspectives. In particular, we could ask what are the affordances for any particular tissue or stage of progression or type of cancer, and which is to ask what mutations are selectively advantageous from that point, and that will help us predict what's likely to evolve. I mean, that's not a question that's not a framing we've used in the past in cancer biology, and I think it's a productive one, both for human cancers and for non-human cancers.
Yeah, if I
Amy?
could just kind of dive in there, I think, the key of a definition, why definitions are so important, is they bring clarity to discussion. They also reveal worldviews. They reveal the worldview and get your worldview wrong. And you can work really, really hard and be super, super smart, and yellow fever and malaria will still kill all the French people that tried to dig the Panama Canal. Get your worldview right, like Walter Reed, who wasn't terribly smart necessarily, and who did a totally despicable experiment, Havana. And it allowed probably less well-trained engineers to dig the Panama Canal. So I think the stakes are too high. If you look at the trajectory of cancer and other diseases or ways in which we die, obviously mortality rates from cancer are going down. We celebrate. We're doing great. But in fact, because mortality rates from heart disease, from dementia, from neurological disorders, from cardiopulmonary, from strokes, they're going down faster. So all of us that are on this have a higher likelihood of cancer contributing to our cause of death than 30 years ago, than 40 years ago. We're not keeping up with the Joneses. And I think, and of course, this is Bob. I'm sorry. That's why Bob sucked me into the field, and why I love being in the field and working with Bob is the reason, is that if you don't approach it as a disease of ecology and evolution, and you try to approach it with coming up with a better statin for heart disease, a better drug for Parkinson's, a better drug for Alzheimer's, as Bob will always say, evolution by natural selection is a lot smarter than we are. So I think the definition is not only useful for us as researchers, I think it is going to be key to what is the likelihood of our children and grandchildren dying of cancer or something else.
Yeah. And
damn those cardiologists, they're making us look bad.
That's right. Before I get to Amy's question, I do want to add a caveat, or maybe a note of humility, which derives from Joel's point about worldview. Obviously, I'm an evolutionary biologist, so I'm biased to see all of this in evolutionary terms. And this is the International Society for Evolution, Ecology, and Cancer, so we're preaching to the choir here. So I acknowledge that I probably have blind spots, and I have have preferences. I prefer to see cancer as an evolutionary system. That being said, I think this is the right way. I think I'm right. I think we are right. And I think the proof is in the pudding in terms of what it does for us in terms of helping us understand and treat cancer better. So I think that's the referee in that debate about who's right and wrong will be utility, essentially. But
Exactly.
let me go to Amy.
Yeah, thanks. This has been a great conversation. We started talking about all definitions describe what cancer does, right? And so I have a really hard time with the definition ending in causes lethality because
Mm.
it's still what cancer does. And I don't have a solution, but like I do have
Well,
like
I would say focus on neoplasm, right? What came to me from all this work was the central importance here is the neoplasm. And
Yes, I see.
and so cancer for me is sort of a practical layer on top of that, but the heart of all of this is understanding the neoplastic process that's dynamic. Um, so you can ignore the cancer distinction if you want because it's what it does and what's going to be in the future, but you can't ignore the neoplastic process.
Okay, fair enough.
All right, we're near time. Does anybody want to have a last swing at the ball?
Maybe I would want to say that one question for the future, if this definition is one we want to proceed with, is going to be how practical it is. And so, for example, there is still the question, like if we want to use this definition to ask a question such as, is this thing a neoplasm or not? How easily are we going to answer this question based on our definition? I think it's not that trivial and it may require a number of experimental validation, for example, to prove that the proliferation is uncontrolled, that it's due to cell level evolution. So maybe there is also something here that we still need to dig in.
So actually, we are doing this. We're sampling a cactus and the cresting in a cactus with this very question, is it a cancer? Is it cell level evolution? And this perspective helps us with that experiment because now it says we need to sequence those tissues, show that there's somatic mutations that are in the control of cell proliferation. So I think I'm happy with this definition because it really does allow us to expand way beyond the human context and give us experimental purchase on the problem. I do want to acknowledge Cameron had a comment in the chat saying, do you all think there is utility in trying to compare and contrast a definition of cancer to definitions of other diseases with replicating agents like tuberculosis? Does
And
anybody want to?
I would say absolutely, because I sit on a committee of somebody who's studying the transmissible cancer in devils. And of course, as an evolution, of course, now this is self-serving, Carlo and Ron. This should be sort of again with a modicum, probably a huge dollop of humility. But then what makes cancer interesting as an eco-evolutionary process is the patient, is the planet Earth, which means then there is no evolutionary feedbacks to try to protect the patient or not protect the patient. Everything is just death as an unintended consequence, all of this. However, as soon as it's communicable, and so Cameron, as you know, as soon as you have an infectious disease, now virulence and transmissibility. Now the host is a food patch. It's just a transient patch in that evolutionary context now. And so I think absolutely, but I think where it really drives home is that when you're dealing with infectious diseases, when you're concerned about the evolution of resistance, drug resistance, it's not so much that that one patient won't be curable. It's that somewhere among the millions of patients, a resistant bug will evolve and then ruin it for everybody. Whereas, as Bob pointed out, as we pointed out in a paper in terms of, Stackelberg evolutionary game theory applied to cancer, all of the evolutionary knowledge built into that cancer dies with it. Whereas with infectious diseases, it carries over.
Right.
They bring it along. Anyway, I don't know, Cameron, if that touched upon or if you want to add to that.
Well, I would also say from what Benjamin and Lucie brought up earlier is that a good definition not only sort of gathers together the phenomena that are in the definition, but it excludes the things that are outside of the definition. And so I think looking at edge cases or potential challenges, like is a nodule of tuberculosis a cancer? Are good ways of trying to test your definition to see if you're excluding what we think are the things that ought
That's
to be.
right. And in my committee meeting yesterday, I was telling them that once you have the communicable cancer, it then is no longer cancer. Now, its origin was cancer. It's a new speciation event again. Its origin, it's jumped another type of level of selection. And so at that point, its origin, its cell of origin was cancer. But it's not cancer. And you can see it very clearly, and it goes on an entirely different evolutionary trajectory. Anyway, just a thought.
Carlo,
All
I
right.
just want to point out that we really need to have as our audience oncologists. And if I had $1 for every time an oncologist told me that cancer is too complicated to model, I wouldn't have to apply for grants. Because that's the universal view. It is hopelessly complex, almost to the point of being magical, of being almost an evil entity. And I know that when I was working at Fox Chase, when I first came up with this evolutionary model of cancer, and to me it was a great relief because we can understand this. This actually makes sense, and it's not an evil entity. It's got to obey the rules of evolution like every other, avenue of life, and we can understand those. And so the to the oncologist, what we need to convey is that we can understand this and we can beat it, but because we know the fundamental rules. But that's a tough sell.
Right.
I would not underestimate the importance of that kind of psychological thing that we
I
need to do.
agree.
So the audience needs to be presented at the JCO and the kind of clinical cancer meetings, to really get hold of the oncologist and kind of get them to recognize it.
Great. So our charge, and this is Benjamin's paper, is to dispel the evil magic of cancer. And so that's our quest here.
Yes.
And we're gonna do our best. We appreciate the whole community's work on this. And hopefully we'll see Benjamin's paper in the not too distant future in publication.
Thank
All
you.
right. Thank you all. Thank you, Joel, Lucie, Benjamin, and thanks, Amy, for setting this up. Really
Yeah.
appreciate it.
Thank
Oh,
you.
so fun seeing everybody.
Yep.
Thanks.
Bye,
Okay.
everyone.
Hey,
Thank you.
bye-bye.